Okay, we are going to look at some example problems from geometry. The big issues we had this week were when we were asked to find the slope of a perpendicular line or of a parallel line. And it wasn't so much the definitions. Instead, it was the transformation of the equation into something where we could find that information easily from the equation. So if you have the worksheet for that given class, Unit 2a, on Tuesday, I'm going to look at problems 6 through 15. I'm not going to do them all. I'm going to do some of them. Just use them for examples and talk about how we manipulate them to solve for y, and what information we can pull from them. So the first one I want to look at is number 13. So we're going to start off with y plus 2 is equal to 1/4 x. So keep in mind that we always want to try to get to slope-intercept form. And you all are pretty much aware of this, y equals mx plus b. Now, the thing is, how do we get this equation to look like that? So there's two basic things. One, we want to get the y by itself. And then two, we want to have everything else over here on the right-hand side of our equation. So to do that in this case, it's going to be us just subtracting 2 from both sides. So what happened this week was we would have people who tried to take 1/4 x and subtract it minus 2. So say 1/4 minus 2 and get an answer from that. Remember, you can only do that with like terms. So you can only add or subtract like terms. So what we mean by like terms, in case you don't remember, is they have to have the same variable or they have to have no variable. Right here we have 1/4 with the x, that's our variable. And right here is minus 2, no variable, so they can't really add. So what we end up doing is, since this is 2 minus 2, we'll just have y equals, and we'll just do bookkeeping basically, 1/4 x minus 2. Okay? So another misconception, now that we have it in y equals mx plus b form, another misconception we had was that our slope in this case would be equal to 1/4 x. That is not true. Okay? Our slope is a number. It is not a term. So that means there is no variable with it. When we talk about the slope, we talk about the coefficient of x, the number in front of the x. So our slope, in this case, will be 1/4, and our y-intercept will be -2. Okay? So when we talk about the slope of a perpendicular line, okay? So the slope of a perpendicular line. So by definition, the slope of a line that is perpendicular to our line, or perpendicular line, is what we call the inverse reciprocal. And if you were in my 7th period class, I probably spelled that right. I keep spelling it wrong. So Miss Jago is not here with me today, so hopefully I spelled it right. So inverse just means, and like we talked about, to change the sign. Meaning we go from a negative to a positive, or from a positive to a negative. Okay? Reciprocal just means to flip it. Okay? So if we have a fraction, the reciprocal is 4/3. All right? If we have -2/3, our reciprocal is -3/2. Now, for those of you who got this concept, you're thinking you did something wrong, you did something different. I haven't put the two together yet. And when I put the two together, we'll see what we can do. So let's take our slope over here. We have a slope of 1/4, okay, that we found. So our slope of our original line was equal to 1/4. So the slope of our perpendicular line, and I'm just putting a little perpendicular symbol there. I'm writing the perpendicular slope in orange, but I don't know. In case you're colorblind, you'll have the little symbol there for perpendicular so you know what we're talking about. So we're going to do the inverse. So the inverse of a positive 1/4 is a negative 1/4. And now we're going to do the reciprocal part, which is the flip. And so if I flip this upside down, I now have -4/1, or I can write it as -4. Okay? So the slope of my perpendicular line is equal to -4/1. Sorry, I had a stray mark. I don't want to confuse you. Or -4. Okay? It's one of those two. Now the slope of a parallel line is much easier. We didn't talk about it much. So the slope of the parallel line, and again, our symbol for parallel, the slope of the parallel line is just the same. So if the slope of the original line is 1/4, then the slope of the parallel line is also 1/4. Let's look at a few more examples. Let's take a look at let us take a look at number let's take a look at number 10 from the example. We may have worked it out in class, but just in case we went too fast. So this is number 10 on that same sheet. So we have 5y is equal to 5 plus 4x. And again, we wanted to get to in slope-intercept form. So our slope-intercept form is y is equal to mx plus b. Now, if you're having trouble with this exercise, it may be helpful for you to go through and write this every single time you do the problem. I know it seems redundant, I know it seems pointless, but it helps to reinforce what the slope-intercept form is. And as you're doing it, you're also telling yourself, this is my slope, this is my intercept. What I'm trying to do is get y by itself and everything else on the other side. So the way that we can do that on this one, we have 5y equals 5 plus 4x. So some people struggled and said, well, man, maybe I should subtract a 5. Maybe I should add a 5 to both sides. Maybe I should try to move this 4x. Again, think about what you're trying to do and then make logical steps towards that. So when we say logical steps, what do we have? We already have something with x on the right-hand side. So why touch it? We already have something that's just sitting there as a regular number. So again, why touch it and move it? The only thing we don't have what we wanted is y by itself. Okay, so let's move this 5y. And for those of you who may have forgotten, when we have a number next to a variable, that means that we're multiplying. So a number and a variable sitting right next to each other with no sign in the middle between them, it means we're multiplying. So the opposite of multiplication, to move this 5 over here, we're going to have to divide. Now, when we did this in class again, some people said, oh, that looks different. I don't like the way that looks. How do I deal with that? How do I address it? If you're in one of the other classes, I'm not sure which period, but one thing we may want to write it when we divide on this side where all this stuff is here, we may want to do it piece by piece. So we may want to say, I'm going to divide everything by 5 and write it that way. So now we can see our 5's cancel out. We have 5 over 5, which is 1, and 4/5 x. So we have it really close to mx plus b form. Let's just rewrite these in order and we'll see it. So then from here, we can say what our slope and intercept are. Our slope is 4/5. Our intercept B is +1. And again, taking a look at our perpendicular slope, the slope of our perpendicular line, we know that our original slope is 4/5. So we're going to do our inverse, which gives us, since this is positive, this is going to become a -4/5. And then we are going to do our reciprocal, or our flip. So that's going to be turned upside down. So we'll have it that way. Okay? For our parallel line, remember we said the parallel is just the same. So if the slope of my original line is 4/5, the slope of my parallel line is 4/5. Let's take a look at one more example. We'll do one with fractions, since you guys love the fractions. Let's start off with number 14. So we have -1/3 y minus 7/15 x, and that's equal to 1. Again, don't get scared. Write the slope-intercept form and start making logical decisions. mx plus b. So what do I have? I already have a number over here on the right-hand side. Let's just keep it there. Let's not play with it. Let's not move the y, because I want the y on the left-hand side. Let's move this, because this I want on the right-hand side of my equal sign. So I will rewrite it so it's a little bit clearer. And what I'm going to do to move this is just add 7/15 x to both sides. And again, don't try to add 1 and 7/15. They're not like terms. And we just have this. Now we're faced with this problem right here, okay? We said that, and we'll write a little brief aside real quick. We talked about how I can rewrite this as y/3. Okay? The reason why we can do that, and we did talk about it in class a little bit, the reason why I can do that is that this is the same thing as writing 1/3 y, sorry, -1/3 y, 1/3 y, is the same thing as writing -1/3 times y/1. Okay, if I wrote y as a fraction, it's like multiplying these two fractions together. And when I multiply these two fractions together, I get -y/3. So, let's look back. So now we have -y/3 is equal to 1 plus 7/15 x. And since this right here, this is division, because under the denominator, this is division. So we're going to do the opposite, which is to multiply. So we'll multiply both sides by -3. Now when we multiply by -3, that means that we're going to distribute this -3 to both terms, okay? Don't just do it on one of them, do it on both of them. All right? So that means now my 3's cancel out. I'm left with y. So -3 times 1 is -3. And -3 times 7/15 is -21/15x. And I'm going to rewrite it in a different order. I'm going to move this over here so that way it looks close to the mx plus b form. So there we go. So that would mean that our slope, m, is equal to -21/15. Okay, we don't take the x. Now, we can reduce this, obviously. They're both factorable by 3, so I can have negative 7 over 5, simplified. My y-intercept is negative 3. So let's take a few seconds and do the perpendicular. So the perpendicular so we are going to have negative 7/5, and we are going to do the inverse. And the inverse of negative 7/5 is positive 7/5. And then we are going to flip and get 5 over 7. We turn it upside down. So my perpendicular is 5 over 7. Let's see. Oh yes, my parallel line. So the slope of my parallel line, we said, is always just the same as my original slope. So if my original slope is negative 7/5, my parallel line is negative 7/5. So there you go. There's the example video for today. It will be uploaded here shortly. Make sure to review it, get notes, and be ready for Tuesday.